Welcome back to the Uptime podcast. I'm your co-host Dan Blewett, and I'm joined here by lightning protection expert Alan Hall. Alan, how you doing?
Great, Dan. How are you?
I'm good. I have a question for you. On a 0 to 10 scale, how healthy are you? How free are you from coronavirus?
I am coronavirus free as of
So like a
right now.
zero? Like a zero?
I'm a 0. My family is still at 0. At least they tell me they're at 0. I think
Okay.
my whole community is actually at 0. I don't think. Well, I'll take that back. That's not true. There's a nursing home about a quarter mile from my house, and I think they had 17 cases in that nursing home, which is
Yikes.
really disappointing. Really disappointing. So they're suffering over there, but it sounds like they got a handle on it actually, which is good. How are things your way?
They're fine. I mean, the reports of it now spreading potentially by like micro droplets, like potentially just from being
Yeah.
breathed on. Like that's just like there's not much we're gonna be able to do. I mean, that's
Gotta
rough
start wearing the
because
mask. I'm telling you, you're going to be
well
wearing
my
the mask.
that's all well and good except you have to make them yourself. I mean, you can't buy
That's
one
okay.
anywhere. So yeah, actually, my sister is gonna make some this weekend and ship one to me. Um, she's like, I have some old cloth that we're gonna use. It's supposed to be cotton, so it's like okay,
I got
but
berated the other day. The FedEx guy was coming up to the house, and it was a package I've been waiting for. So I popped open the door and reached out the door, and my wife grabs me and says, "You can't take the package. He's got to set it on the ground, and then you can go pick it up." Oh, yeah, you're 100% right. I did not think about that because I've never done that before. But
mm-hmm.
he should have just thrown it at me, and it would have been fine. Uh, but I wasn't thinking about it. Yeah,
Yeah, I went to the post office today, and just not a great. It's a very tiny location, so it's like a little box, almost like the size of, I don't know, like a late night little like just dip in and grab a burger kind of place. Like it's
yeah,
very small, and
yeah.
there are like 3 or 4 other people there, and I stood my 5-ish probably feet away from everyone, but
Yeah.
I was like, I shouldn't be in here. But then if you walk out, then you're never gonna get in line, and then your whole day is stuck at the post office.
Yeah.
So I don't
Yeah.
know. It's problematic, but they said it might be transmissible through the air. So
Yeah, that's the thing right now. I saw,
yeah,
was it today where I saw the recommending that you wear a mask, whether you think you have it or not, because you're contagious before you know it. When my wife went to the grocery store, what happens to be in our neck of the woods at a Walmart, and when she got back today, she said most of the people in the store were wearing masks. So I think we've jumped the cultural hurdle on masks is because
probably.
if it's happening here, it should be happening in most places.
Yeah. And now if someone was to rob a bank, you like wouldn't even flinch. You'd be like,
Right.
"Oh, you're wearing a mask for that reason." Oh, okay. Not
Okay.
coronavirus. Yeah, so when we do get back to normal in the fall, we're going to be all desensitized to people wearing masks.
Yeah.
It's going to be trouble. It's going to be
Yeah,
trouble.
it
We
will.
need
Yeah, it
we need
will.
superheroes or something.
Right.
I don't know. But anyway, so how is this affecting the renewable energy sector?
It's just like everything else. Parts of it are in complete shutdown.
No
Factories
people to do the work, huh?
Yeah, well, I think everybody's got to try to keep their distance, right? So anything that's closed office intensive, where you're packing in a bunch of engineers in a small space, has been stopped, and they've sent everybody home.
Yeah.
And then the manufacturing areas, they're either working to spread people out from one another, so not working in close proximity to one another. And from what I've heard, because had a couple of phone calls this week talking about this, which all this makes sense to me now. And I've seen this in action, but I never really thought about it this way. But what they're doing is they're taking the employee's temperature before they come in and then providing them with a wristband. So they're coming in with a wristband that says, "I'm corona free," or "I do not have a temperature." So you go to work, you got the wristband on, you're doing the separation thing. It sounds like in some places they're handing out masks for people to wear while they're in the workplace, and then on the way out they get their temperature checked and they go home. And then
Hmm.
the second kind of, I think is a smart thing to do if they can do it, is to go from one shift to 3 shifts. So taking that same group of people and spreading them out over 24 hours, an 8-hour group into 24 hours. So it's a third, a third, a third over the workday. So you're not in close proximity to everybody. So it's just like, it just forces separation to happen, but people can still earn a living.
Yeah.
It's yeah, it's if they can pull that off, they're doing it. But um, some of these wind turbine things are really labor intensive. Where if you're putting a wind turbine up and you got a lot of construction crew, they're going to be in close proximity to one another. There's no way getting around it. So those projects, a lot of those projects have been stopped. Obviously, countries that are hit hard will cease some of those things. I expect parts of the United States will stop for a while. It sounds like Italy will stop wind turbine work for a while. Spain probably will. Any of those places have been hard hit, where it's the virus has spread slowly over a wider area for a longer period of time. Governments are just going to shut down those things because they could be postponed. That's what's going to happen. So we're going to see basically a shift, moving all the schedules to the right. So things that would have happened in July are probably going to happen in September, October.
Yeah, and it seems like just getting people out to repair them and maintain them and just hit
Yeah,
that normal just maintenance schedule is going to be really difficult.
it's going to be difficult. Well, and a lot of if I think they try to balance separation and safety, worker safety, versus productivity. Somewhere they got to draw a line, right? And if
Hmm.
you put in the precautions and you're doing a lot of the checks on temperature and people not coming to work who feel like they're ill, it does make it for a safer environment. And then obviously people that are in those risk categories are just being told to stay home and don't worry about coming in until this is passed. That's also smart. So uh, breaking up the groups of people and trying to do the best for them, and also try to provide energy for the sector is also important. So everybody's trying to weigh those costs and trade offs right now.
Yeah, and so talking about labor intensive, wind turbines are getting bigger and bigger and
Yep.
bigger.
Yep.
So manufacturing is getting obviously more complex. Transportation of just like single blades that are now 107 meters long is getting
Yeah.
more difficult. So, but then once they're up and running, hopefully they're reducing a lot of the upkeep and they're just pumping out more power for less windmills out there. So,
Yeah.
what are some of the challenges that some of the scale is providing the industry?
Well, the first, from a just a operation standpoint, you're going to have to transport these things, and you're going to end up building new factories. So, like the LM factory that has been just being built, that's making the Haliade blade for General Electric. So, the new factory in Normandy, France. Uh, you're going to put it somewhere where you can get next to the shipping dock, so you can get the blades on a ship and take them where they eventually will end up at. So you got to, in a sense, you got to build a lot of expensive infrastructure to make blades that big. And then obviously from the design standpoint, you really want to make those blades last as long as you can. So from the lightning protection standpoint, you really want to do a lot of testing on it and make sure that they're going to perform as you think they are. As when the blades get to 107 meters.
Yeah,
They're not me, right? In the United States, that's a football field, right? That is a long way. And it makes the total diameter about 200 meters when the blade's spinning around. That's a big area. Uh, when the blades get that big, they're going to be using carbon fiber in those blades because you need more fiber strength because of the way the weight and the load is. So some part of those blades will have carbon fiber in them in a spar to stiffen them up where they can handle the loads. That's a huge deal, putting carbon fiber in any sort of blade, because it's conductive, and lightning energy tends to go down to anything that's conductive, right? It's parallel paths. There's a down conductor in there, I'm sure, and then some part of that energy is going to get to the carbon fiber. And how do you handle the lightning energy going into it, lightning energy going out of it, and do it safely? So
yeah.
that's a big design challenge.
Yeah, so reading down the spec sheet, so the Haliade X, which is a GE turbine, it's
Yep.
12 megawatts. This is the
Wow.
world's biggest new wind turbine. 12 megawatt output, 220-meter rotor diameter, which is insane. Like you said, 107 meters per blade,
Yeah.
and 260-meter total height. So it's
Yep.
about
Yep.
800 feet with the top blade pointing straight vertical, which is just just got to be terrifying just being near them.
Well, they're
So
going to be out in the
big
ocean, right? Or no,
for the
they're
most
not on the
part. Yeah,
ocean. Yeah, they're all. I think they're in. Are they on the ocean or on the land there? Aren't they
they're
up in
they're s-
Holland?
they're slated to be offshore for the most part.
Okay,
Yeah, yeah, yeah.
yeah.
I
Well, they'll
mean,
probably
most
put one on land just so they can test it, right? They would have some
they do
similar.
have a prototype. Yeah, I think it's near Normandy Beach is where their factory is in
Yeah.
France. But I mean, yeah, they're stacking this up in some of their graphics. These are almost as tall as the Eiffel Tower. I mean, they're
Wow.
just like it's
Eiffel
insane.
Tower's
So
big. Yeah.
it's not small, although I haven't been out there, but I've heard reports that it's not small. Um, but yeah, I mean these things are so big where I don't know how you even start to get repairmen up there. I mean, there's just going to be more and more challenges, and like you said, with
Yeah.
the shortage potentially of workers
Yeah.
and transportation, and they're going to want these. They said the capacity factor is 63%, which is really high. So they're going
Yeah.
to try to keep these running as much as they can, because one of these can power up to 16,000 homes, which is crazy.
That's a lot of homes.
It's a lot of homes, and they're
Yeah.
going to be in really, really rough terrain. Well, not so much terrain, but just rough seas. With
Sure.
lots and lots of wind. So,
Yeah.
I mean, keeping them going is going to be difficult. So, you said you came across some research recently on down conductors that's
Yeah.
probably relevant in this case.
So there's a new paper out on lightning protection for wind turbine blade. It's produced by looks like a number either students or professors. I can't tell, but the name of it is called "Lightning Protection Methods for Wind Turbine Blades: An Alternative Approach." Uh, the paper is based on wind turbines. It looks like it's really based upon a Vestas wind turbine blade, an 80-meter or 85-meter long blade, in terms of what the analysis is. So they use a computational analysis using ANSYS, which is a sort of an industry standard computational program. They're using the student version of it. But essentially, what they were looking at was the down conductor and how different diameters of down conductor, uh, what the effects they had was they carry lightning energy. So they were simulating a lightning current flowing down the down conductor and then calculating what the temperature of the down conductor was and the change in the length of the down conductor. So as a wire gets hot, it gets longer. All metals tend to do that at different rates depending on what kind of metal it is. So they had started off with basically a smaller diameter down conductor, theoretically put current down it, big lightning current down it, and then predicted what the temperature was. So in the smallest case, which I think is 50 millimeter cross section, the temperature rise was about 600 degrees Celsius. That's a lot. In Fahrenheit, it's over roughly 1,200 degrees Fahrenheit. That's hot. And the growth of the down conductor was about 1.5 to 2 inches. So it actually got 2 inches, 1.5 to 2 inches longer over that 80-meter span. Two implications are: one, as a down conductor grows, it puts stress onto the blade wherever it's held down at, so that down conductor starts to move, tries to make mechanical other things move. But the second part is that the temperature gets so hot that a lot of that heat is transferred into the structure of the blade, and because the down conductor is on the inside of the blade, where a lot of the load is carried on a wind turbine blade, you can degrade the load-bearing structure inside the blade. That's a problem. And so they had done calculations and simulations of 50 millimeter cross section, 100 millimeter cross section, 200 millimeter cross section, and watch how as you got bigger diameter, the temperature dropped, considerably dropped, and the growth of as the temperature went down, the length of the down conductor varied a lot less. So they were essentially what they were saying was, you're going to need a certain minimum diameter, and you need to be thinking about the temperature rise of the down conductor so you don't damage the structure and that you don't put extra stress onto the blade structure. So it's an interesting paper that way.
Okay, so yeah, I mean, I guess you don't think about the radiant heat coming from the down
Yeah.
conductor. I mean, there's so much energy in a lightning strike. So, what do you think is the future as far as protecting all of that? I mean, is it just getting a thicker down
It is.
conductor? Is it insulating it better, or what?
Well,
What's
the first step is to get an understanding of how much heat is actually being developed there and making sure that the structural engineers understand that and can tolerate it. On other composite structures, on a typical aircraft structure, usually you're your number you want to stay below is 180 degrees Fahrenheit. You don't want to get above that number because mechanically the structure will never regain its strength. So once you get it above that number, you start degrading the mechanical strength of the structure. Um,
And does that start with the
yeah,
resin? Does that start with like the carbon fiber, or is it? I mean, sure, they all have different points where they start to really see negative
yeah.
effects.
So it depends. It's mostly the resin system. The fibers don't care. Carbon fibers is basically burnt material to begin with. Fiberglass is a pretty high. It can handle some high heat. What can't handle the high heat is the resin system. So you're actually physically changing the molecular nature of the resin system, so it's not as tough as it once was. That's essentially what it is.
Gotcha. So most of these strikes are probably going to end up going through the down
That's the
conductor. I
goal.
mean, probably, or yeah, that's the goal. But most of them are probably going to go there by way of the
Yeah.
receptor. You'd
Yes.
hope. So, is the receptor itself, is that a weak or strong link in that
It's
chain?
actually a weak link in the chain, because the receptor is actually handling a lot of the lightning energy. Lightning energy is coming in on the receptor, so there's a lot of heat from the actual lightning channel on the receptor. So the receptors are pretty much always getting hot because there's thermal effects from the lightning channel and being close or to the lightning channel, which is roughly 10,000
Mm-hmm.
degrees Celsius. So a lot of that, in a metal structure, it'll get hot just because of the connection. So the receptor is going to get hot, and the structure around that, the composite structure around that, is going to get hot also. Uh, but usually out towards the tip, there's not a lot of structure there, not a lot of load bearing structure there. So it is less critical. What's more critical as you go down towards the root of the blade, if that's where a lot of load is. So if you're getting that structure warm down towards the bottom, that's going to have implications further on. So if we track lightning strikes to blades, or just I track just blades breaking, right? Because some of these blades that I think are breaking in the field, particularly if they have carbon fiber in them, is that there's lightning energy either sparking to the carbon fiber, or the carbon fiber is taking some of that energy, and it's getting the resin system hot. It's not immediately breaking when the lightning strike happens, but it's weakening the blade. And then as the service life continues and continues and continues, those weaknesses become exaggerated to become failure points and things break. So that's what you're trying to
Gotcha.
avoid, is that you've damaged it or weakened it. It's not going to fail immediately, but because of the loading and the unloading and the loading and unloading and all the flexing and bending that's going to happen, you fatigue it. You basically fatigue failure it, and that's what you got to watch out for. So something as relatively simple as the cross section of a piece of copper wire can have really significant structural implications on the blade.
Gotcha. And obviously, when they strike different portions, so say like they hit the nacelle, they can burn up some of the grease and in like the gearboxes
Yeah.
and stuff like that, and they can also provide cause some long-term damage that you're maybe not going to pick up for a while.
If you have a fire up under the cells, hopefully somebody notices
Yeah,
it.
you're gonna.
Yeah, what tends to happen in the nacelles a lot of times is in order for those generators to run and all the systems that are required to get them to run properly, there's a lot of instrumentation. So there's a lot of sensors and wiring running around inside the nacelle. And when a lightning current runs through there, all the little sensors and the wiring in the sensor for the sensors picks up lightning transient noise or energy, and can damage a sensor, weaken a sensor, fail a sensor. So in lightning strikes, even though the lightning strike may happen to the blade, the current tends to run at least in some part, through the nacelle where the electronics and control systems are, and then down the tower. And what you see is failed sensors. The big one for us several years ago was failed anemometers. So anemometers measure wind speed, and they kind of stick out the back of the nacelles typically. Those things were, in certain installations, were failing like fuses. So anytime they even took a near
Mm-hmm.
strike, they would fail. So all the electronics inside of there in the nacelle are the weak spots, and you're seeing a lot of changes over the last several years on protecting the equipment inside the nacelle.
Gotcha. And then like things like bearings, I mean,
Yeah.
do they have any sort of way to divert energy out of there? Because
Yeah.
again, like same thing, if their lubrication gets heated up too much, it's going to break down and then they're
Yeah.
going to fail.
You see this effect on turboprop airplanes where there's bearings involved between the propeller and the airplane in the engine themselves. The same thing happens on wind turbines. They try to divert the current around the bearings, provide the energy path around the bearings, not through the bearings, because what will happen is you'll pit the bearings, and again, you created
Hmm.
this small imperfection in the bearing, and as the bearing wears over time, you can get these uneven wear patterns happening, and you can have early failures of bearings because the lightning energy has damaged them. Bearings on a wind turbine are big, and so they're not as delicate as a turboprop airplane. In a turboprop airplane, you get struck on the propeller, you're going to end up taking the engine out and replacing the bearings. On a wind turbine, you're not going to do that. It's a lot of work to do
Yeah.
that, and so they tend to let it ride. Uh, but they put systems in wind turbines to sort of avoid going through the bearings. It's smart. That's a smart thing to do. It seems to be pretty commonplace right now. You don't want to put any sort of lightning energy into any mechanical interface that you want to live for a long time.
Yeah, because I was reading that I guess typical like maintenance and upkeep is running around $4,000 a
Mm,
month
I
per
can see that.
turbine.
Yeah.
So yeah, I mean, just talking about getting people out there, and these are obviously highly skilled people with a pretty rare skill
Yeah, it
set.
is.
So, and then obviously the expense of getting them out there, rigging them up, keeping them safe, and now with the coronavirus, all that stuff, that's getting even more
Yeah.
challenging. So yeah, I mean, having some pretty robust measures in place to keep them going is
Right.
probably more important now than ever.
It is obviously uptime, like our podcast is called, is all about keeping the turbines running, and the industry is getting more and more concerned and spending more and more time and energy in making sure that those turbines meet their intended service life. And making small changes is the way to do that. Small improvements, modifying things over time, learning from what our field experience is telling us will make those blades and those systems live that 20-year lifespan.
Yeah, and you wonder if now with again with so much of the social distancing and not knowing how long we're going to be doing
Yep.
this as a planet, you know, I'm sure the drone market's probably picking up where a lot of companies are saying, "Hey, look, we're not going to be able to get people out there, so we need to probably invest more time and money into getting our people comfortable with drones
Yeah.
and just a way to get more people and maybe replace some of those jobs that probably not repair jobs obviously, but just
Inspection jobs.
I'm sure a lot of companies are sinking more time and money into inspections via
Yeah.
drones because you just don't know what the climate might look like in 4, 5, 6 months. There could be a relapse of coronavirus. There could
Oh
be
boy, I hope not.
it's going to be a challenging time when we sort of reopen society in the U.S. and other places where people could suddenly be back in pubs and concerts and movie theaters and it spikes again. Like that's going to be hopefully what we avoid. But as a company, you think, man, maybe this should just be our time to shift to more robust online
Yeah.
systems and more web conferencing and just more use of drones and
Yeah. Automation,
just
computerization, robotics are going to become more commonplace than ever. And not that we didn't have the capability 6 months ago to do it, but we didn't have the desire to do it in a lot of cases. And that's going to change quickly because in the wind turbine industry, delivery of power is essential. And so we're going to do everything we can to keep the power being produced. And that means less regular maintenance. If we can spread out the maintenance times, that's going to help. If we can automate some of the things, if we can provide more information about each of the turbines and do things uh, remotely or smartly, we're going to do it. And there's going to be a in my opinion, there's going to be a dramatic shift over the next couple of months. There's going to be a lot of changes in human ingenuity put to work to make things better. So if we get in this situation again, it seems like every 5 to 10 years, we're kind of in this situation, not as severe as this particular one, but we're probably going to be back in it again in 5 to 10 years. And are we ready for that? And this is the time to learn from our experience, make those changes now, so when we get to the next one, we don't have to go through these big impacts.
Yeah, absolutely. And that's why it probably just makes sense for a lot of companies like, hey, this is the inflection point.
Yeah.
Like, let's just change some of our systems, and we got to be, because I mean, God help a lot of companies who maybe aren't fully online right now, because there's still a lot of, smaller companies that just like they're writing tickets by hand, they're writing invoices by hand, they're filing. They've got a lot of old, it's like, ugh,
Our bank asked us to fax something in today, and I couldn't believe it. I could not believe it. Like, what? I could text it to you, maybe. I do not have a fax machine. That was in the 1980s and 90s, guys. Yeah.
It's
baffling because they've never been in this situation before where there's no one in the office. They don't know how to transfer information securely except via secure fax of some sort. So, yeah, we're all learning a very painful lesson right now.
Yeah. Well, Alan, I think we're going to sign off here today, but thanks again for another great
thanks,
talk.
Dan.
For all of you out there listening, thanks for being here. We appreciate it. If you are new to the show, be sure to subscribe. We're on iTunes, we're on Spotify, we're on YouTube and other podcast platforms. And be sure to check out our YouTube channel if you're an engineer, you're just interested in the industry, because we have lots of short clips. So if you want a quick soundbite, you have something specific that you're looking for, whether it's in lightning protection or something else, check out our short clips, because they're an easy way to just grab the info that you need and go. Our goal is to be a big help to anyone working in the industry who needs to learn a little more about lightning protection, just wind turbines in general. So we're going to be a good resource there out on YouTube as well. So not just here on iTunes or Spotify, but in video form as well. And definitely check out our website, weatherguardwind.com, and shoot us a message via email or set up a Zoom call, and we will get you taken care of if you need something. So thanks again for listening, and we will see you here next week.